Hey everyone, we're going to look at a complex fraction problem that has a little bit more challenge to it than the previous video. The problem that we're going to take a look at is going to be as follows. We're going to have 2 over x squared plus 1 over x, and that whole addition of rational expressions is going to be over 4 over x squared minus 1 over x. One of the most common errors that people will do is they will look at the second terms of 1 over x on the top and that 1 over x on the bottom, and they will want to cancel them out. This is an erroneous thing to do because we would be canceling by terms and not by factors. So remember from the previous video we had mentioned that you're not actually reducing the fraction, you're dismembering it. So if you are dismembering it, you are wrecking its value. If you're reducing it, you're just slimming it down but maintaining its true value. So we do not want to cancel term by term. Here is what we want to investigate. I'm going to rewrite this problem and kind of color code it. So I'm going to say we have 2 over x squared plus 1 over x on the top, and I'm going to keep my giant division bar. And then I'm going to divide that by the 4 over x squared minus 1 over x. So I'm going to focus my attention on what I have in the top portion of that complex fraction. And what I would like to do is I would actually like to combine them. So I want to use my 6.3 material here. I want to add those two rational expressions. So in order to do that, I need to find the common denominator between the x squared and the x. So this is going to be very Blue's Clues here, but what's the common denominator, or least common denominator, excuse me, between x squared and x? Feel free to shout it out wherever you are while you're watching this video. I promise I can hear you. Very good. Yes. The common denominator here is x squared. So notice that the first term already has the x squared denominator, but I need to multiply the second term by an x over x. So notice I'm not changing the value, I'm really just modifying it so that I can combine. So at this point I have 2 over x squared plus x over x squared. I have that common denominator happening. So I'm going to go ahead and kind of fast forward and say this is going to be 2 plus x all over x squared. Since I have that common denominator, I'm just shorthanding that fraction. Okay? So now we can focus our attention on what is happening in the bottom half. So again, we have a denominator of x squared and x. Again, what is the least common denominator between these two? Again, say it loud and proud, everyone. Yes, yes, calm down. It's okay. So yes, it should be x squared. So again, I have to look at the second term and I need to multiply the numerator and denominator by an x to make sure that the fraction's value does not change. So this is going to give me 4 over x squared minus x over x squared. And again, I'm going to go ahead and shorthand it. So I know that the common denominator here is x squared, so I'm going to have a 4 minus x in its numerator. So if you had seen the previous video, we had looked at something called the least common denominator method. Note that the denominator of the top rational expression is x squared. The denominator of the bottom rational expression is also x squared. We can quickly just reduce them out. They're gone. So this leaves me with 2 plus x all over 4 minus x. At this point, it's just cleanup. Take a look at the top, or the numerator. You have 2 plus x. You should ask yourself, is there anything I can factor out between those two terms? Do a 2 and a variable x have anything in common? At this point, you should be screaming at the screen, no, you cannot do that. And I would politely and calmly reassure you that yes, you are correct. There's nothing in common, so we have to leave it. Again, we can move to the bottom into the denominator and say 4 minus x. Is there anything in common between the number 4 and x? Again, everyone, calm down. You are right. There is nothing that is in common, so we cannot factor anything out. So finally, we would say that the solution is just 2 plus x all over 4 minus x. There is nothing in common. Remember, in order to cancel out anything, we need to cancel out factors, not terms. So again, we want to avoid that urge to reduce the 2 with the 4 and the x with the x as well. Treat this as a number. 2 plus x is not the same thing as 4 minus x, so they cannot reduce with each other. Okay? We don't know what x is for sure, so we can't be presumptuous and assume that we can. So we leave it as we see here what I have circled. I hope this was helpful.